Hello, everyone. I hope you can all hear me well. Good evening to all our attendees located in Europe, and good morning to everyone who might listen to us from the America region. Um, I'm happy to welcome you to our today's PointSense Plant session, introducing you the latest features in our new version 17.5 to you. My name is Katrin Falz, and I'm your moderator for today's meeting. And with me is my colleague, my sales colleague, John Bunn. He's one of our sales engineers in US, and I'm really pleased to have him on board for presenting the new enhancements in PointSense Plant to you today. John has a really profound and long years knowledge and experience in demoing and using the software. And from the American side, I guess you know John personally as well. The meeting is also accompanied by our former, we say internally, product owner, PointSense Plant product owner, Oliver Pringman. And Oliver, is also available to answer your questions you may have during the presentation. And I'm happy to have him in the call as well. The meeting, the meeting will be recorded. This meeting, and you obviously have already dialed in using your browser and headset. You will be in a muted mode, so you can just listen to this presentation. But of course, we enable you to ask your questions. For doing this, please use the Q&A icon you can find on the right hand side of your, or you should find on the right hand side of your window, and ask your questions whenever they occur. We have a slight delay in getting our voice and image or screens shared to you. So whenever you have a question, just type them in right away, that we will all have it present at the end of the presentation, and that we are able to answer it live. And this has been the short introduction for today's meeting, and now I'm happy to hand over the microphone to John. And I wish you a good session.
Thank you, Katrin. So first, I would like to just kind of go over the agenda for this presentation. We're focusing on what's new with PointSense Plant. So this is sort of with the basis that you have an understanding of what was, in the product in the previous releases. So we're just focusing on the new features. Obviously, the new version is compatible with AutoCAD 2017. We have various improvements to the piping and the structural, which you'll see videos and slides on. Walk the run is much faster, which you'll see. Steel, we're going to go through, having stacked steel support. We're going to have importing and exporting advanced steel catalogs. And then we're going to get into some of the other features that are actually in the Pro building and plant product, but most notably SmatSnaps, profile fitting, and a much more robust deviation mode. So as far as the compatibility is concerned, we are compatible with all your major versions of Windows. As I stated before, we're compatible with AutoCAD 2017. As before, we have special functionality for Plant 3D users, but essentially all your AutoCAD verticals will work with this product. We also do continue to support the recap point cloud format. And for anyone using 2013 or 2014, we still are compatible with that, but that is using the PCG engine. So getting into some of the new features here, this is, in my opinion, one of the most noticeable improvements in the software. This is pre-calculation of cylinders. Now, we're doing this slightly different, and when I say that, I mean, we're actually calculating all these cylinders, putting them on its own layer, and they're sort of hanging out there in the background. We're using that in our walk the run to enhance the accuracy and the speed dramatically. And it also gives the product the ability to see fittings much further than we could before. For anyone who's used the software a lot in the past, I'm sure you use the other pipe option quite a bit. In the new version, you almost never have to use it. And I myself was a huge proponent of the other pipe button. It's how I traditionally taught it in the trainings. It was traditionally how I used it in the web demos. But you almost don't have to use it at all with this new version, and it's much faster, much more accurate, and much easier for the users to use. But like I said, as before, we're still doing that sort of semi-automated approach where the user is tasked with verifying the preview that we give you and then hitting the insert and continue button. So just to give you an idea of this, when you start walk to run, you're going to have a new button here, Precalculate Cylinders, and it's going to calculate everything that you have loaded. Or what you have on screen. So if you do have an area clipped out, it will calculate just that area. Now I've actually sped up that progress bar there. This actually took about 4 minutes to calculate all the cylinders. And so what I'll do here is show you on the layer, or on the hidden layer, all the cylinders that we found. Now we're only using these to get you your correct axes and diameters. But now if you notice, when I do walk the run, it finds things much quicker. So it already found my elbow. I'll actually zoom in here just so you can see it a little bit better. It'll find the elbow. It'll find the pipe. Pipes stretch much further than before. In this one here, I'm just going to extend it out to the end here. On the second run, you'll actually see how quickly it finds the pipes and the elbows without the user having to do other pipe at all, or having to wait for a search. So we'll do walk the run again here. Now you'll also notice the arrow kind of pointing which way to go. That's a new feature as well. You can always just hit your enter key to accept that direction. But if you notice here, all I'm doing is hitting insert and continue, and it found the 90 and the 45 almost instantaneously. That was actually real speed there, or real time. So I wanted to do sort of a tip or a trick that I've found works really well with walk the run. And just to give you an idea here, we're starting off with the point cloud kind of zoomed out. My first thing I want to do is jump into scan navigation. I do that because it's going to limit you down to one scan position. Now this is real time. I did a clipping box, and you're seeing this take about, I think, 7 seconds in order to find all the cylinders in that area. And the reason I did this is to show you that if you only need a small area, go ahead and clip it out. Then you can turn all your points back on, and you're going to see how quickly it can find all these fittings. So there it found the pipe. It's got the T with the branch and the run. It found the elbow, and then it found the next elbow. I can almost not even narrate as fast as the software is finding these fittings. And this is real time. So anyone who's used this in the past, you should immediately notice how much faster and more efficient walk the run is. Another thing that we've added here is cutback support. You'll see a new checkbox for cutback elbows. Then if you right click on one of the cutback elbows, you will get multiple options on inserting that elbow as is, or inserting it at its original or catalog based value, or you can actually change the cutback angle if you want to round off the number, for example. Another thing to note is if you are using Plant 3D, this supports Plant 3D cutbacks. We've also improved the look of fittings. Most notably, in my opinion, are the flanges. And these are on generic fittings. For anyone who's actually importing in their own Plant 3D specs, you'll still have your custom look that you've always been accustomed to. But in this case, you can see from the left to the right here, the difference in flanges is drastic. And it's a huge improvement when you're trying to line something up to back of face, for example. I'll show you the new generic look. We've got a pipe with a reducer coming down. I'm just going to continue from that reducer and choose the flange here. And again, this is just a generic flange, but it looks like a flange. The only thing that we're missing really is the bolt pattern or the bolts, but that's normal. So same thing here with the valves. You can see here, even a generic valve now has a hand wheel. If you were to import these from Plant 3D, however, you will get a hand wheel length or a stem length that matches what is defined in that catalog or in that spec. But just kind of wanted to show here that you can definitely see it's a much cleaner look. And again, this is just for generic fittings. Another nice improvement that we've added is the ability to assign line numbers to fittings as you're doing them. You'll see it at the bottom of your walkthrough on dialog box. There's also a way to add these in the property box, which we'll show as well. But if you set this line number here, it will stay there. It will also give you a drop down that will offer all line numbers that have been added in that drawing. With the properties window, and we'll see this in the video coming up, our parts now have real properties to them. So you'll see the description, you'll see which catalog or really which spec they came out of. You'll see the line number, and you'll also see insulation, which is a really nice feature because you can actually adjust all objects' insulation thickness at the same time. So we're just going to continue from that same part that we just modeled. And the first thing I wanted to show here is just in the walkthrough on dialog box before you've inserted any fittings, you can go down here and change the line number. And again, if you have multiple line numbers in that drawing, they will be available to you during this pull down. Now, what I'm doing here is highlighting the object and showing the properties. You see here, there's no line number, no insulation thickness, but I can manually type it in here. And if you highlight multiple objects, you can do the same thing, which is actually really good if you want to assign all these objects to a line number, maybe after the fact, maybe you forgot to put one in, or maybe you need to change the line number. Or if you want to change the insulation thickness, you'll notice all the fittings actually update to take in that new insulation thickness. So as far as the structural catalogs go, we've included the option to bring in your Advanced Steel catalogs. For anyone using Advanced Steel, I'm sure you are very familiar with the fact that they are massive catalogs. They're very customizable. They're very specific on the descriptions, on the material, on the standards used, but they are much better than the traditional Plant 3D structural steel or the Revit steel catalogs. So you have the ability to bring those in. You also have the ability to use our standard steel fit routines as you always would. And then at the very end, you can actually turn those into advanced steel objects. One of the, in my opinion, probably the biggest improvement to the steel is the support of stack steel. And you're going to see two things that sort of support this. One is being able to change the axis or axes of the structural members, either automatically or manually. And then when you do apply constraints for steel, you'll see that they can actually, instead of trying to meet at a center line, they're actually meeting at their most likely axis. So this is kind of what I was saying here. You're going to have in the past where this orange piece is here on the left, it used to try to fit on a center line and it would kind of just blend into the other pieces. In the real world, a lot of these pieces need to actually attach on the side or, on top of each other. So we've actually fixed that, and we've also given the users a visual feedback on how they're going to fit before we actually fit them. Now, before I start this video, I want you to pay attention to this part right here. This is an option that we have where you can turn on the axis of the steel members. We have an automatic and a manual way to set those. And you can always turn that off, but I leave it on when I'm trying to determine, how the software found it or how it's treating them. So what we're going to do here is use the align beam axis. You can choose multiple beams and change them all at once if you want. You can see here I'm just clicking on the steel and changing the axis where I want the other piece of steel to meet. So now I do apply constraints, as we used to do. And you'll see that it actually runs up to the bottom instead of trying to go all the way up to the center line of the steel like it did before. And again, you can do this on multiple pieces. So, if you have 20 horizontal parallel beams, you can say, I want all of their axes to be on the bottom of the face. This is really just more of an improvement versus a new feature. In the past, when we had multiple pieces of steel meeting up at a single spot, they would get close to that location, but they would not quite fit up. Um, it wasn't really a bug, so to speak. It was just kind of lacking on its accuracy. So just letting everyone know that these do actually meet up a lot better now. As you can see on the right, they're going to meet up at that specific point. And all it has to do, or all it needs, is to be within a specific tolerance during apply constraints. The smart snaps, in my opinion, is one of the better features that it has been put in across all the pro building, plant, etc. products. What smart snaps is the ability to snap to very specific points within a search region. For example, you have your corners and edges, which I think are probably going to be the ones that are most used. You also have a high point and low point. But in this case, the user doesn't have to zoom in and get right on that edge in order for us to find it. You just need to be within that search region that you can see around the cursor there, and the software will look for those edges or corners as you go through the routine. And you won't see this circle until you actually initialize a routine like 3D Polyline, for example. But once you do start one of those routines, you'll see that radius, that search region come up, and you just need to make sure that your edge or corner that you're looking for is within that radius. If you can kind of see here on the left side, we have a preview that we generate as you click the point. You have an auto mode that you can turn on or off, but if you leave it on, it will actually plot the point for you and give you a confirmation on the left. Now, what you're seeing on the left there is actually, 3 different vantage points or viewpoints of that specific point. And you're going to see, it's kind of hard to see here, but there's a green dot in the middle of each one of these previews, and that is telling you where that point is. So it allows the user to verify that, yes, it's on an edge from a plan view and from an elevation view, and you can just, you can tell that the software found the correct point for you. On this example here, I turned it to a normalized color mode. It just makes the faces easier to see. You can see my smart snap on the left there. You have an option for corner point. You also have an option for corner or edge if you want, but if you notice, as I'm clicking points, my cursor is not on the edge. Like I said before, the edge just needs to be within that search region. So it allows you to stay zoomed out. It also allows you to move much quicker through the data. And also, if you were to zoom all the way in to try and get an edge, a lot of times the point cloud gets less dense, and it's very hard to see where the edge is. If you notice here, I've switched to a corner mode, and now I can just go from corner to corner to corner, and it's drawing that floor plan all the way through there. In this case, I actually used a 3D polyline command, so it is drawing this in 3D. But if you did it in a 2D polyline command, you would actually get this projected on a single elevation. This is extremely useful. It's also very useful for doing high point, low point. If you're trying to get like a swale or where something would drain, maybe in a parking lot or on the road or on some concrete, it's very easy for you to find low point and high point without having to actually search for it. So fit profile is another new routine that we've pushed throughout most of the products. It has a couple of different output options. But essentially what it needs is for the user to create a 2D profile, and then we will find it along a path. And as you can see in these previews here, the path can actually curve in order for the software to still find it. So it's great for doing curbs. Sorry about that. Great for doing curves, great for doing, let's say, gutters, bent steel, twisting steel, stuff like that. For the example I had here, what I did is I actually had some train tracks here, and it's hard to see right now, but there's a very little profile there at the bottom right. All I do is tell it to search from one spot to another. You have the output option of the profile in 3D space, and then you have another option to actually loft those into a surface. Now, whenever it completes the search, you can actually remove certain profiles if they didn't fit. And usually that'll happen if you have gaps in data. But you can see here, fit very nicely throughout the tracks. And like I said before, it will work on anything that curves. It doesn't just have to be a straight path or straight profile. Colorizing by deviation. This is very similar to what we had before with the cylinder analysis and planar analysis, when you had the option to export out a point cloud. For anyone who was using that before, essentially what you would do is export a point cloud, and then you would bring that cloud in and change its color mode to intensity. And it would actually be color coded based on its deviation from that object. It was first introduced in the cylinder analysis. A lot of our customers were using it for tank deformation, but then it was brought in for planar analysis as well for walls or ground features. What we've done here is given the user the ability to take any solid or any solids and compare them to the point cloud. We then create a new cloud that's color coded based on its deviation to the 3D geometry. So what I have here are two pieces of steel. I've actually exploded them into AutoCAD solids. And then what I do here is just choose those objects and tell it where to save the new point cloud. When you're inserting this new point cloud, just remember to insert it, inches to inches or feet to feet. It needs to be a 1-to-1 scale because we're actually creating it in the current scale of the drawing. So what I'll do here is bring in that point cloud, and you kind of can't see it behind the solid modeling here, so I'll just turn it to a wireframe. And like I said before, if you change it to intensity, you'll get the color coding of how well the point cloud matched with the solid. And just like in the past with any of our sections or point clouds, you can right click on the section, choose Insert Legend, and create a legend to basically signify how or the deviation that each color represents. So in this case, I gave it 1/8 of an inch intervals, and then you'll see here is just telling you, essentially red is from 0 to 1/8, which we saw, the majority being red, and really nothing was worse than 1/4 of an inch off. Okay, so another little trick that I like to do, or that I like to show, if anyone here has used PointSense for Revit, we had an analysis tool, or it's called Calculate. What it did was it would take any solid that we had and color code the solid itself to show how far it deviated from the point cloud. Very similar to what we saw here, just kind of opposite. We call it the point cloud in AutoCAD, but the solid in Revit. But the trick here is, what if you don't have PointSense for Revit? But what if you work in Revit or you've received a Revit model from a customer? What if you want to see how those line up to the point cloud, but you only have PointSense for AutoCAD? So the trick here, go ahead and open your Revit model. And when you do the export to CAD format, do not choose DWG. You want to go with the SAT option. The reason for this is the ASIS or SAT object is natively supported in AutoCAD as a 3D solid. If you export DWG, it will give you polyface meshes and block references. And we cannot compare the point cloud to that. So what I did is I went ahead and brought in the SAT file. I'm going to use the analysis tool and select whichever solids I want to compare to the point cloud. Now, what I'm actually comparing in this example is a set of cabinets or drawers. So I have those selected. It's going to generate a point cloud once I give it, a place to save to. And then, like we did before, change the intensity value to get the deviation results. But again, this is a trick for people who do not have access to PointSense for Revit, or they need to see these results in AutoCAD. Some people have PointSense for Revit, but they still want to see this in AutoCAD. So it's a really nice feature. Plus, it gives you the ability to create a brand new point cloud of just the part that matches the solid or the solid geometry. So you can see here we have those cabinets done. And then if I change it to intensity, you get your very nice heat map showing, how far the cloud or how much the cloud matches the solid. So, and this is more of a user ease of use sort of thing. Um, but you'd be surprised how much more convenient it is. In a lot of dialog boxes, wherever we could, we decided to put a way to change parameters on the fly. In the past, you'd have to do things like escape out of everything, go to your point cloud parameters, or maybe your config wizard, and go change those values. Um, you'll see that there are many places where you have the parameters listed in the dialog box and you're allowed to change it on the fly. So it just kind of avoids you not having to cancel a command and then jump out to a different routine. The analysis tools for cylinder analysis, planar analysis as well. We've added a lot of features that make it easier to read or easier to work with. For example, on the planar analysis, you have a checkbox for square grid. Really what that means is instead of having to go in and say 5 feet and then go to the next value and say 5 feet again, you can put a checkbox in there, and then when you set one value, it sets them both. It's kind of like locking an aspect ratio. It's the exact same thing. As far as the text readouts, or when you create a text file of the data, we have new labels in the columns. You can see here the X and the Y in the world coordinate system. Just makes it easier to see, or easier for the user to know where it's at. In the past, we just kind of listed them out and you had to count the grids. So it wasn't very user friendly or user readable. So now you can actually see the coordinate information and know exactly which grid it's talking about. Another really nice user improvement is the section manager. I'm sure a lot of you on 17.5 noticed this one almost immediately. You have the ability to change your point cloud point size directly from the section manager, which is great. And you also have the ability to set a transparency from the section manager. Transparency is one of the greatest options for being able to see your work without having to completely turn off the point cloud. In the past, users had to really uncheck all of their visible sections to turn them off just to see the work that they were doing. And in this case, now all you have to do is set the transparency, and it'll stay at that transparency value even when you uncheck it. So if you set it to 60%, for example, and check it, you'll be able to see your modeling. Then when you uncheck it, the cloud will go back to its 100%, opaque view. But the next time you need to do the transparency, you don't have to set it to 60 again. You just put the checkbox back in. I'll show you a video on this. You'll see how much it helps. So right now the cloud is at its full transparency value, and I'm just increasing and decreasing the point size on the fly. Previously, you'd have to highlight the point cloud and change that value in the special ribbon that pops up. But here you can see now I'm changing the transparency. I can turn it off or on, whenever I need to, whenever I see fit. But it helps to kind of find where you're at and find out what you've modeled. Now, what we've also done is when you click the scan navigation button, we also do a transparency. This is so you can see those spheres easier, and so you can actually highlight them through the point cloud. I'm sure everyone who's done scan navigation, has come across the problem where you can't see the sphere through the point cloud. So that's a very nice feature to help users move around more quickly and without having to turn the point cloud off completely. Some other improvements that we've added, we have a one-click plane option and an automatic rim option, both within that modeling plane section. But they've received some very nice features that make it more understandable and easier to use. One of the ones that I really like is on the command line, you have an increase and a decrease option. So you don't have to go into the parameters dialog box and actually change that search radius value. It's very similar to like in Microsoft Word, where you can just click a button to increase the text size or decrease the text size. Works very similar to that. So it just avoids you having to go into that parameter dialog box, change the value, and then go back, and then do that multiple times till you get the right radius. The other thing that we've added is the ability to no longer create sections by default, or without the user being able to turn that off. So you have a new checkbox here where you can either create the section in the point cloud manager or in the section manager, or if you uncheck it, which I usually do, it will not do that. So typically I keep that unchecked. I'll do the one-click plane and let the plane sort of grow. And for anyone who has not used this feature, it's very useful for being able to trace out a complete facade at its real shape. So if you were to click anywhere on that wall, for example, it will actually take the plane and make it grow to trace that shape. So I know we went through some of that stuff pretty quickly here. Katrin, are you in the audio there?
Hi, John. I'm here again. Thanks really a lot for this great presentation. I think I speak in the with voice of the customer. It really showed how easy and efficiently the extraction of pipe and steel components, as well as other line work, works now in the latest version. And feels like the software has really just made another step forward for providing more powerful tools for extraction data from point cloud. So I will just take a look to the Q&A box now to see if we have received some questions. As I encouraged you beforehand, just if you feel like asking something to John or Oliver right now, just type in your questions. You have the chance now to ask them directly. So let me see. Well, yes, we have received questions here. So one question comes from David. He's asking, is Faro providing more robust structural catalogs even if I don't own a program like Advanced Steel or Plant 3D?
Yes, actually, it's very similar to if you did not have Plant 3D, could you still use our catalogs? And the answer is yes, because we're actually able to create them and we provided them with the software. With the Advanced Steel stuff, we're actually able to create those catalogs right now with what Advanced Steel currently provides. The only thing you will not be able to do is if you don't own Advanced Steel, you won't be able to create custom catalogs or refine them down. So if you have a custom, a set of custom pieces, there's no way for us to get those in. Or if your client, for example, uses Advanced Steel and wants you to use their specific objects, you won't be able to do that from your machine without having Advanced Steel.
Okay, hope that answers your question. John, we have another question coming in. It's some lines here. I read it out slow that you can get it. It's coming here from David. And is it required to use the auto cylinder extraction before using walk the run for piping? And then another question, how big of an example have you tested on so far, and how long did the extraction process take to complete? And then another sentence, finally, I noticed an intermission, but what does this mean?
Great question.
Yeah,
No,
okay.
I got it all. So first answer is no, it is not required, but I promise you will want to use it. If you do not do the cylinder detection, it will work like it did in 17.0 and 16.5. So it'll still work just fine. We'll still be able to detect diameters, axis, everything like that. But it'll be much slower, and you'll find yourself having to rely on the other pipe button or doing placement by circle, those features. On a large, or I'll put it this way. So if you're doing it on a single scan position of like 25 million points, you're looking at about 2.5, 3 minutes to detect that. And it also depends how many cylinders are physically in that data. But you're looking at 2.5, 3 minutes for that. and you only have to do it once. You don't have to do it every time you do walk the run or every time you jump into that scan position. So what I usually do is I'll open up an example and go ahead and just generate all the cylinders. Leading into your second question, I have a scan that was 20 or a data set that was 27 scans, right at 500 million points, I believe, or just below 500 million points. That took, I want to say it was like 32 minutes. I mean, and that's, a one-time thing. So you save the drawing after that. In the last thing that you were saying on the intermission, you actually have two buttons there. You have an intermission and a finish button. The finish button will stop it at any time and keep the cylinders that it's already found. The intermission button will allow you to pause that search, do whatever work you need to in AutoCAD, and then return to it later. It just has to be within the same drawing session. It's really just a pause button.
Okay, great, John. There came just another question in here. It's coming from John, and he's asking for the SmartSnap, can you adjust the radius on the circle on the fly, like the last feature you just showed? Increase and decrease for the one-click plane?
Yes, I apologize. I should have mentioned that. And it's actually a really good way to do it too. So if you hold down your shift key and move your middle mouse wheel, that radius will adjust for you.
Okay, perfect. Another question that just came in. Are all of these cylinders slowing down AutoCAD? Seems like many objects. Yeah, I guess this is referring to the pre-calculation tool.
It doesn't slow down AutoCAD very noticeably at all, and the reason is because it's on a hidden layer. What it will do is increase the file size. So what you want to do is when you're done, you basically just turn on that layer, get rid of all your objects, and your size will go back down. But no, it does not slow down AutoCAD much at all. On that example where I had the 27 scans, yeah, there were a ton of cylinders. I want to say it was like 100,000 almost. I forget the exact number, but it was a lot. And a lot of those were valid cylinders because I don't know if you noticed it in the example, but there was a ton of piping going on above the steel. There was equipment everywhere. There was conduit. There was drains. Instrument assembly all over the place. But like I said, it was on a hidden layer. So AutoCAD doesn't really slow down that much until it's having to regenerate things visually. So yeah, you should not notice much of a slowdown, if any.
Okay. Currently looks like there came no other questions in. Just as a question, Oliver, do you still want to add something to the call, or I think John already covered all the great new feature stuff we have included. So just to know if you want to.
No, thank you. It was really a great presentation. I think I couldn't do it like you have done it for us, and I'm think that and I would be happy if you enjoy to work with our software as much as we did during developing those features, and we are happy to get your feedback, maybe via John or other salespeople, or directly to me or Jana. Yeah, let us know what you think about this release, and what are your wishes for the future.